Look up at the night sky. Beyond our clouds, past the protective blanket of our atmosphere, lies a vast, silent, and ancient expanse that has been expanding relentlessly for billions of years. For centuries, humanity looked at these distant stars and wondered where it all began, questioning our place in this grand cosmic design. Today, modern science gives us a definitive answer. Everything we see, everything we touch, and everything we are, started from a single, infinitely hot, and infinitely dense point in space. But how did a chaotic, violently exploding universe eventually give birth to a perfectly ordered cosmic neighborhood? How did random cosmic dust transform into the solid world we step on today? This is the ultimate story of our solar system. It is a profound journey through deep time, extreme gravity, and catastrophic cosmic collisions that built our home from absolute nothingness. To truly understand this journey, we must first travel back to the very dawn of time itself, long before the sun, the earth, or any planets existed. The universe was a wild, uncharted frontier of pure energy and subatomic particles. Over vast stretches of time, these particles cooled and formed the very first elements, hydrogen and helium. These gases drifted across the emptiness of space, forming massive, structureless clouds. Under the relentless pull of gravity, these clouds began to gather, compress, and ignite, giving birth to the first generation of stars. These ancient stars were cosmic factories, fusing simple elements into heavier ones like carbon, oxygen, silicon, and iron. When these massive stars reached the end of their life cycles, they exploded in magnificent supernovas, scattering these newly forged elements across the dark corridors of space. It was from this enriched stardust that our own solar system would eventually be sculpted. Imagine drifting through the dark void of our galaxy roughly 5 billion years ago. In this specific region of the Milky Way, there was no bright sun to warm the darkness, and no planetary orbits cutting through the vacuum. Instead, there was only a colossal, ghost-like cloud of cold gas and dark interstellar dust stretching across light years of space. This immense structure, known to astronomers as the solar nebula, floated quietly in a state of delicate equilibrium. It was a quiet reservoir of raw potential, waiting for a catalyst to awaken it. That catalyst arrived when a massive neighboring star met its violent end in a spectacular supernova explosion. The resulting shockwave ripped through space, slamming into our peaceful nebula with unimaginable force. This disruptive energy shattered the nebula's internal balance, forcing the spread-out gas and dust to compress violently. As the particles were shoved closer together, their mutual gravitational pull increased exponentially, causing the entire cloud to begin collapsing inward under its own massive weight. As this immense cloud collapsed, an extraordinary physical transformation began to take place. Conservation of angular momentum dictated that as the nebula shrank, it had to spin faster and faster, much like a figure skater pulling in their arms during a spin. The rapid rotation caused the chaotic cloud to flatten out, transforming from a giant, shapeless blob into a rapidly spinning, ultra-hot protoplanetary disk. At the exact center of this swirling vortex, an immense concentration of matter was accumulating at a staggering rate. Gravity was pulling the vast majority of the nebula's hydrogen gas into a central core, packing it so tightly that the atoms began to grind against one another, generating friction and sending temperatures soaring into millions of degrees. The pressure at the heart of this spinning disk became completely unimaginable, creating a celestial pressure cooker of cosmic proportions. This central concentration of mass grew heavier and hungrier by the day, drawing in more material from the surrounding disk. It became a glowing, hyper-dense ball of plasma known as a protostar. For millions of years, this protostar grew brighter and hotter, accumulating more than 99% of the entire nebula's material. The stage was being set for the defining moment in our cosmic history. When the core temperature finally crossed the threshold of 15 million degrees Celsius, something magical happened. The immense pressure forced hydrogen nuclei to overcome their natural repulsion, smashing them together so violently that they fused to form helium. This process, known as nuclear fusion, unleashed a staggering torrent of pure energy, traveling outward from the core and fighting against the inward crush of gravity. In that brilliant, blinding flash of cosmic ignition, our sun was born. The newborn star unleashed a powerful solar wind, a fierce gale of charged particles that swept through the surrounding disk, blowing away the leftover light gases and clearing out the immediate space around it. The ignition of the sun fundamentally redefined the entire region, establishing a powerful gravitational anchor that would permanently govern the movements of every object nearby. The sun was now the undisputed master of this new territory, a glowing powerhouse fueling the center of our system. Yet, the remaining fraction of a percent of dust and rocky debris left behind in the spinning outer disk held a very special, intricate destiny. This leftover material was not merely waste, it contained the heavy elements, the metals, the silicates, and the ices that would soon become the building blocks for an entire family of diverse worlds. This brings us to the very edge of a new era of planetary creation. The story of our solar system shifts from the birth of a star to the complex, chaotic construction of its surrounding companions. It is a narrative driven by the laws of thermodynamics, orbital mechanics, and random, violent chance. Every planet, moon, and asteroid we observe today is a survivor of this ancient, competitive era, shaped by the unique environment of the early solar disk. As we prepare to dive deeper into the specific chapters of this cosmic architecture, we begin to appreciate the sheer scale of time and probability required to build a stable system. We are looking back at a history that spans billions of years, analyzing the precise mechanisms that turned a spinning cloud of dust into a functional, harmonious astronomical system. It is a journey that challenges our understanding of nature and highlights the profound beauty of cosmic evolution. Let us step forward into the deep archive of space and witness the incredible step-by-step formation of our cosmic oasis. What emerged from millions of years of violent chaos was an exceptionally fine-tuned and delicate cosmic machine. Every single planet settled into a specific, mathematically stable orbit, contributing directly to the structural balance of the entire system. Our cosmic neighborhood is not just a random collection of isolated rocks floating in a vacuum. It behaves like a highly coordinated protective shield. Take the gas giant Jupiter, for example. Because of its colossal mass, Jupiter possesses an immense gravitational field that alters the trajectory of incoming space debris. It acts as a massive cosmic vacuum cleaner for the inner solar system. Without Jupiter pulling in or deflecting dangerous long-period comets and stray asteroids, the inner rocky planets would be subjected to catastrophic impacts on a regular basis. It effectively clears the path so that smaller worlds can exist in relative safety. And this brings us to the most remarkable anomaly in the entire system, our planet, Earth. Earth is positioned perfectly within a narrow astronomical boundary known as the circumstellar habitable zone, or more famously, the Goldilocks Zone. This means our planet is situated at the precise distance from the Sun where it is neither too hot to boil away atmosphere nor too cold to freeze everything solid. This incredibly rare positioning allows liquid water to remain stable on the surface. Liquid water is the fundamental, non-negotiable ingredient that allowed organic chemistry to spark, evolve, and ultimately thrive. The journey of our solar system is far more than a simple history lesson about rocks, ice, and expanding gas. It is quite literally our own origin story. Every single atom that makes up our physical bodies, from the iron rushing through our blood to the calcium structuralizing our bones, was forged deep inside the hearts of ancient, dying stars. This material was swept up in that spinning solar disk billions of years ago. We are a living, breathing testament to the ancient history of our universe. Out of a chaotic, unfolding universe spanning billions of light years, a highly specific and unique sequence of cosmic events conspired to create this fragile, safe harbor we call home. When we look at the sheer scale of the cosmos, it becomes undeniably clear that we are not separate from the universe, but an intrinsic, living part of it. We are a rare and beautiful byproduct of a grand, 14-billion-year-old cosmic journey, a conscious way for the universe itself to look back, think deep, and truly know its own magnificent architecture. Every breakthrough in modern astronomy and every image captured by our deepest space telescopes reminds us of how remarkably fine-tuned our solar system is. From the protective heavy gravity of Jupiter to our perfect positioning in the Goldilocks zone, our existence hangs in a delicate, cosmic balance. As we continue to look out into the deep, silent unknown, we realize just how extraordinarily precious, rare, and irreplaceable our small corner of the universe truly is. The cosmos is still teeming with profound mysteries waiting to be solved, and our collective journey of discovery has only just begun. If you want to continue exploring the hidden secrets of our cosmos, the deep mysteries of space, and the incredible history of the world we inhabit, make sure to hit that subscribe button right now. Don't forget to turn on notifications so you never miss a step on our grand journey through time and space. Join us in the comments below to share your thoughts on the origins of our universe. Thank you for watching, for staying curious, and for exploring the grand design of the cosmos with us today. Until next time, keep looking at the stars.